whatever malicious apps you can think of, most likely they were present on Google Play. Now I will continue with a brief analysis of these apps, their functionality, what they did, and how to prevent getting infected. Let me start with the fake apps. Which one would you install? One on the left side is official Instagram, on the right side is fake app. As you can see, they have same icon, application name, developer name, and even positive height rating. When you don't want to end up with such application, you should check rating as well as comments of other users. In this particular case, also number of installs, because official Instagram has 100 million installs, and the fake one had only 100. The purpose of the fake app was only to display ads. It wasn't actually harmful to user. But this changes. Which one would you download now? This service is cryptocurrency wallet, my Ethereum wallet. One of them is legit, one of them is fake. As you can see, they share same icon, application name, developer name, positive rating. I asked on Twitter, what would people do? What would they choose? And from over 500 votes, 40% would go for malicious app. What's the worst thing is that this fake app has better rating than the legitimate application. So in this case, you cannot apply a rule, check the rating, and check the comments, because they would be most likely fake. In a case of downloading applications that requires your credentials or your sensitive personal information, I always advise people to go to the web page of the service, search for mobile application, find the link to Play Store, and this is the app you want to download. Purpose of this fake app was to steal your credentials. Now imagine a scenario. Your smartphone is lagging. There are some pop-ups, weird notifications, some ads. You even find some application that you haven't installed. A lot of traffic going in and out. What do you do? For many people, this is the first time when they go on the Play Store and download Antivirus, security solution for their smartphone, right? And they search for highly rated, for 4.6, and popular. This app had over 500,000 installs. Max security. Once you install the ad, open the app and scan with that application or smartphone, this app actually tells you that this app has higher risk and advises you to remove it from your device. This is fake antivirus. On Play Store, there were over 40 apps with altogether millions of installs. They shared the same functionality. They impersonate legitimate purpose, a legitimate app, legitimate functionality, and they decide whether app is clean or bad based on whitelisting and blacklisting of activities, package names, and permission. It's not enough. I did some tests on my own, try to bypass the security solution, and when the bad guy decides to pick package name, which is a unique ID for the application of, let's say, something popular like Facebook, Twitter, Telegram, something that is inside whitelist, application gets passed, and you are still infected. What you should do, download only trustworthy security solutions. Which are trustworthy? Well, Google them up. From fake apps, move on to popular category you probably know for Windows, it's Adware. Purpose of Adware is to display unwanted advertisement to the user. All these apps were found on Google Play Store by Trend Micro. I think it was either this year or in the end of last year, and they had over 90 million installs. Adware malware family got upgraded, and for last 3-4 years, we detect new malware family that is actually based on Adware. It's called Hidden App or Hidden Ad. I found these apps, 16 apps, on the Play Store in November last year. Altogether, they have over 500,000 installs. They are a bit more dangerous and without any functionality. Once user launches the app, it downloads additional payload from the developer server and makes user install something that is necessary to play the game, Game Center. Once user installs the app, both of the apps from Play Store and payload will hide from user's view and only deliver ads. Once user unlocks his smartphone, there's a full screen ad. After some time, there's time delay, there are ads. After you run different applications, there are ads or fake weird notifications. The most dangerous thing about them, comparing them to Adware, is that developer decides what kind of payload will be downloaded. This can be changed. Move on to ad fraud. New category for a couple of years on Play Store. The purpose of ad fraud is to either hijack impressions of ads or click on ads without user knowing to generate ad revenue. Maybe you know, maybe new application AS File Explorer Manager, one of the most popular, over 100 million installs. It's not available on the Play Store anymore because it contained ad fraud functionality. Really similar to ad fraud is clickers. They are on the market since 2014. The purpose is the same. Click on ads in the background without user knowing. The first clickers were clicking every 60 seconds on ads. Well, first clicker were clicking on porn ads to generate a lot of traffic. So if a user is all day on Wi-Fi, he maybe doesn't care. But once on mobile data, it takes a lot of data. I did a test on that, and within 1 hour, it could generate over 100 megabytes. These were latest clickers found on Play Store in the June or August last year, I have found. They actually contained real functionality. The first one didn't. And after some time, they would download additional payload that is then installed or dynamically loaded. This payload is responsible for clicking in the background to generate ad revenue. These were clickers. Move on to phishing, but not phishing for banking credentials, mostly for social media. One of the most popular is a stealer or Instagram stealer. I found a couple of apps with thousands of installs. Their purpose is to steal your credentials and send them to the attacker server. However, there's a business model. All these stolen credentials are then used as a service for other people to generate likes, clicks, comments, follows on Instagram. Another application, this app was actually paying to user to watch ads. Once user earned a couple of dollars, he needs to log in to his PayPal account through this application over HTTP. Credentials were then sent to the attacker server. And of course, phishing for Facebook credentials. From phishing, move to cryptocurrency. Cryptocurrency scams, we actually know 3 different types: fake exchanges, fake cryptocurrency wallets, and coin jacking or crypto mining on infected device. Now the question is, why and when this happened? In the end of 2017 and beginning of 2018, when the Bitcoin went to all-time high, almost 20K, exchanges, wallets, and services were not prepared for that. They didn't have actual applications. At that time, bad guys stepped in, created fake apps, upload them to App Store, and they were waiting for credentials. Once user launches them, they have nice user interface, but credentials are stolen. The same applied to cryptocurrency wallets, including the popular services as My Ethereum Wallet, MetaMask, and others. For crypto wallets, it was a bit different, because once you install a cryptocurrency wallet, there is generated wallet for you. In this case, it was only displayed wallet of the developer, of the bad guy. So once user decides to deposit cryptocurrency, he doesn't own the private key. Only bad guy can withdraw from that wallet. And the last type of cryptocurrency scams are miners. Backsmasher found on Play Store, over 1 million installs. This app contained shared library that was mining Monero on all the infected devices. Android Clipper, a latest infiltration that was found on Play Store. Android Clipper is kind of new for Android ecosystem. The first Clipper was found in August last year by Dr. Webb. This one I found, this is actually the first Clipper on Play Store. The purpose of Clipper is to exchange cryptocurrency address of the recipient in a clipboard. This app impersonated MetaMask application, and here is how it looks. Imagine scenario, you want to send cryptocurrency to some of your friends or pay to services. You copy the address from the website and you paste it into the recipient folder of your wallet. Clipper will exchange the address for the address that belongs to bad guy. If you don't realize that, if you don't double check the copied and pasted address, you send your currency to the bad guy. In this case, this Clipper could hijack only Bitcoin and Ethereum wallets. Even spyware was presented on Play Store. This is the last one found by Trend Micro. It's called Mobbed Spy. 6 apps on Play Store with over 100,000 of installs. Purpose of the spyware was to steal all the personal information, photos, contacts, text messages. It could even phish for Facebook credentials. This campaign is not spread on Google Play anymore, but outside of Play Store using Facebook fan pages that had thousands of likes. These guys are actually not really good with security, because when I analyzed this infiltration, this mobbed spy, I found a couple of open directory servers that contained pictures of their victims, phone records. And there's one more thing I have found, that actually anyone could access their Firebase console and could send global messages to all the victims with custom notification. For example, you are infected, please install this antivirus solution. There was also government malware. This was discovered a couple months ago by Security Without Borders. This was targeted or aimed only on Italy. Almost 20 apps, or something over 20 apps for 2 years approximately. The purpose was to steal all the personal information and send them to the server. Now we are heading to the last category of malware on Play Store, which could be one of the most dangerous category, that wants to access your credentials and want to have access to your funds, to your money, which is mobile banking Trojans. We divide mobile banking Trojans into 2 categories: simple, fake ones, and the complex one. Let me quickly start with the simple ones. Their goal is to impersonate only one banking application. Once user launches the app, nice user interface, credentials are, however, stolen. Once user logs in, there is either some generic error, such as backend is not working right now, please try again later. Or they open Play Store with official application for the particular bank. Well, this is the new app, please install that, we are out of date. Goal of simple banking Trojans is to steal credentials and bypass SMS two-factor authentication. Comparing them to sophisticated or complex banking Trojans, they have a wide range of capabilities. They could be remotely controlled, steal your contacts, text messages, browsing history, record phone calls, videos, and many, many others. But their goal is the same: to get your credentials, but using different methods, comparing to simple ones. And also, they don't target only one application, but whatever apps you have installed. On Play Store, there were a couple of different Android banking sophisticated malware families. The most popular, probably BankBot and Anubis. And now I will continue with analysis of Anubis. Let me quickly start with the genesis, or how it all and when it all happened. Anubis is based on open source code that was leaked or open sourced in 2016 of BankBot, different versions, different variants, and also different branches that were still based on the leaked BankBot. For example, CometBot is now being sold in underground markets for 800 or 700 euros. But it's not sophisticated at all. So that's the genesis of Anubis. Now let's continue with distribution on Play Store. These complex banking Trojans do not impersonate banking apps, as it was with simple ones. They impersonate apps that are useful, that have some functionality. Since we are in Poland, there was also a targeted attack on Play Store with Anubis on Polish users, discovered by Witold. And this is the app, Flaga Polski. It had over 1,000 installs. Now let me quickly go through overview of functionality of Anubis. User downloads the app. What's happening in the foreground? He enjoys the functionality of the app. This is some currency converter. However, in the background, after some steps, I'll explain them on the way. Malware starts to communicate with CNC, downloads second stage payload, requests the victim to install that, activate accessibility services, and targets banking applications. This is a rough overview of what's going on. Now let's dive a little bit deeper. After malware is installed, there are some checks for emulation, if it is running in emulator or on device of the actual victim. There are some checks for strings, for libraries, for package names, the default one. However, Anubis is using one more anti-emulation check, which is actually misusing movement sensor. Because when malware is tested, it's tested either in emulation in your PC or using device that sits on your table all the time. But if it is in a pocket of the victim, it's actually moving. If infected device makes 7 or more steps, payload gets executed. Payload starts to communicate with the CNC by sending information about device and including its name, release, and also which applications are installed, potential targeted apps. Communication is encrypted, and afterwards it requests second stage payload. Before heading to second stage payload, let me quickly go through the communication. Different versions have different type of communication. The first one had hard-coded CNC. Later, they start to use Twitter handles, where they send commands encrypted as tweets. Same was applied for Telegram channels and even Firebase console. For some reason, they used my name in their CNC, Lukas Štefanko, as well as their Twitter handles. I don't know why. Guys probably don't really like me. Latest version of CNC is using or adding one extra step. It requests server from a Telegram channel, then needs to have credentials, and using the credentials can download additional payload. This is most likely done to restrict malware researchers to get their hands on their latest payload. So this was communication, CNC, and infected device. Then there is a request to download second stage payload. Some of them leave their server open, and there's not only one payload, but over 4,000 of them. They have same functionality, and they were most likely built by some tool. Once the payload is downloaded to the smartphone, it's requested to install using social engineering. So the user hits cancel, this activity will reappear. Eventually, user needs to install the application. Afterwards, after some time, there is a request to activate accessibility services for Google service. Accessibility services are there for a reason in your smartphone, in your Android. They are for disabled users, visually impaired users, to help them read the text, zoom in, zoom out, see which application is running. This is misused by Anubis to perform clicks on behalf of user, to see which application is running, and also to keylog all the user input. Now, let's come back. User is requested after some time to activate Google services, and he has no idea. Is it really from Google, from Android? Which app is responsible for this request? Once user hits OK, malware takes control over infected device and perform the clicks. It dynamically allows all the necessary permissions for malware to work. Send text messages, access contacts, record audio, video, and so on. Then malware waits in the background for commands to be executed. The most interesting is key logging functionality by misusing accessibility. It can also disable Play Protect. It has ransomware module, and the core is the phishing. Now I go quickly through Cryptolocker or ransomware functionality. When I tested that on my smartphone, malware received the command, encrypts the files on SD card with its custom encryption, creates .anubis script extension, and then request user to pay ransom. This was ransomware functionality. Move on to core phishing functionality. How it works. Anubis checks for every application that is launched by the user, 24/7, let's say. But if application wants to run 24/7 and scan for processes, for applications, it will be shut down by Android because it wastes battery resources. Anubis bypasses that using accessibility to confirm or actually optimizes battery for itself. Once this is done, malware can run in the background 24/7 scanning for launched applications. If one of the targeted banking app is launched by the user, malware will notify CNC server with a package name of the application, receives the URL link to phishing activity, and this phishing HTML is then displayed in internal web view. This internal web view then overlays a legitimate application and requests user to log in. One in the background launched by user, one in the foreground displayed by Anubis. So that's the for functionality of Anubis. Now let's move on to targets. Anubis targets over 350 mobile applications, where most of them are mobile banking apps from these countries. Besides the mobile banking apps, it targets financial apps, PayPal, shopping apps, Amazon, cryptocurrency exchanges, cryptocurrency wallets, email clients, social media apps, and many others. It also uses persistent technique to stay on infected device as long as possible by misusing accessibility services. Once user wants to manually uninstall the infiltration, detects the package name, displays the fake, this is a system application, it cannot be shut down, removed, kills the activity, and goes back to home screen. Also, all Android devices have by default, or should have by default, enable Google Play Protect solution, security solution, let's say. Anubis disables that after it's on an infected device, and if victim wants to enable that once again, this is the same fake notification. It cannot be done and shuts down the activity. For this year, I've been actually gathering informations of Anubis that was available on Play Store, and I found 17 Anubises on Play Store with over 13,000 installs only in January. These numbers are not from Google, not from Android, but articles, blog posts, tweets from InfoSec community. Now, you are maybe asking, well, it looks really difficult, right, to get actually infected by Anubis. You have to find application. There's another application downloaded that has to be installed, some accessibility services, there are some clicks, some pop-ups, there's a traffic. Recently, I got my hands on a backup from one of the CNC servers of Anubis. There were over 500 victims, and I found out that Anubis is also spread as SMS worm. it sends itself with a URL link to all the contacts in your contact list. And here is one of the logs. Once victim is infected, it sends 150 text messages to their friends. Within 1 minute, receives 3 text messages saying, what is this and who you are. So apparently not everyone in your contact list knows who you are. Within 2 minutes, receives 4 same text messages. The same text messages that were sent to all the contacts. Within 2 minutes, 4 people downloaded the app, installed, got infected, and spread it further to their contacts. The text message says, good app, please install, and link to Google Play Store. This is the application. The app had 1,000 installs and was available for approximately 20 days on Play Store. From 500 victims, 82 sent these text messages to their friends. When I grabbed all the logs, all the results, there was sent within 16 minutes over 9,000 text messages to people you know, your friends, family members, colleagues, and so on. Besides that, it was also successful when gathering credentials for financial apps, including the security questions, banking apps, and also Gmail account, which is really interesting because once the attacker or Anubis has access to your 2-factor authentication device and your Gmail account, which is for many of us primary mail account, he can access other services user is using and reset the passwords. I did some stats on that server, and almost 60 victims actually sent their Gmail accounts to Anubis, fake screens that overlay legitimate application, PayPal, and some banking applications. But that's still not it. There's one more thing, and Anubis 2.5 got leaked in March this year and is available on a couple of underground forums with source code for free. Source code to backend, including the APK builder. What does it mean? Bad guys don't need to know how to develop Android applications. They just simply build them. So that's about one of the recent Anubis banking Trojan that was spread through Play Store. Let me quickly wrap it up. I was talking about the different ways how you can get infected. Outside of Play Store, searching for cracked apps, social engineering, receiving text messages with a link to malware, as you saw in an Android Anubis case. And from Play Store, there were a couple of bad malicious apps on Play Store. I was talking about using the techniques and how you can stay safe. A couple of quick tips. Download apps, only from Play Store. No joking. But before that, check the rating, developer name, check the comments, or the safest way, as I mentioned, when downloading apps that actually request your credentials. Your personal information is to get to web page of the service, search for mobile application. You get the link redirects you to Play Store, and this is the app you want to download. And also do not activate accessibility services to apps you have no idea about. In conclusion, number of Android malware is rising. There is more and more Android devices, more and more Android apps, app developers, and this is a great ecosystem for bad guys to create their malware. Most of the time, they got inspired from a Windows ecosystem, a sophisticated ransomware, crypto ransomware, banking Trojans, Clippers, and others. They bypassed security of Play Store, so actually available to anyone. And there's one more thing, one more takeaway, that even a lack of security of your friends, colleagues, family members can make you vulnerable. Thank you very much.